In this problem, we are going to be trying to find all the solutions in the interval from 510 degrees out to 1050 degrees. So obviously we're in degree mode here. And we'll start by finding the principal value, which I've already posted this little screenshot here of that being done. But the steps I didn't show is when you're given an equation sine x equals 0, you're simply taking the sine inverse of both sides. Okay, it'll be a little bit tight there, but that's to reduce that out and get x isolated, and that gives you sine inverse of 0. So punching that in actually does result in 0, and that's our principal value. And our next step is, as we've been working it out in class, is to graph both sides of the equation and look for equality. So when does the sine of an angle equal the ratio of 0? So you can see I've kind of color-coded these things here with the grapher. Blue for sine, red for the constant at 0, which thank goodness for color because that lands right on the x-axis line. So down below here, I've also taken a second to, in degree mode, what should our window be? Because we're just dealing with basic sine, I am going on an x scale of 90 degrees to see this well. So every 90 degrees, you've got another anchor point, a minimum, a maximum, or a midline value. Our Ymin and Ymax don't need to be real extravagant because the amplitude of sine here is just 1, so negative 1.5 and positive 1.5, and we could label that here as 1 and negative 1. That kind of helps see it a little better. So once I got the graph up and running and a good window here, I should say too, since we're running out to 1050, I made sure to go out to a maximum x value of 1170, just the next multiple of 90 degrees. So that's the end of the window here is 1170, and back to negative 90 at the far extreme on the left. Okay, now that we have our bearings a little bit better here, I traced to 510. So 510 gives us an output of positive 0.5. And so what that tells me is we're looking for all the intersections of the blue and red functions between 510, and then you could see down here I traced out to 1050, and that put me down at negative 0.5. So I wish I could do this all in one graph, so what I'm going to do is transfer that little cursor from here. I'm just going to graph it on the graph on the left. So we're looking for intersection points in this highlighted box, and those are the only solutions we're going to find. So as you can see, I think I'll use pink here, right on the blue and red intersection. That happens 3 times. You can see it in that yellow box, which is between 510 degrees and then 1050 degrees out here. So what we want to do is find out what these x values are. So we want to find that point. I'm going to call number 1, number 2, and the third point, point number 3. So I believe there's 3 correct answers we need to find and choose here in this multiple choice question. So go back to our principal value. That was the thing we found very first in the calculator by algebraically solving for x with the equation sine x equals 0. And that was 0. 0 degrees. Here was our principal value. Now, the periodic nature of the sine function shows us that every period I get to that same point. So if I add 360, I'm going to get to that next point right away. Okay? But it's even better than that because we know that the way sine cycles, and since this ratio of 0 happens at 0 degrees, but it also happens at 180 degrees. So there's actually two patterns going on here, and we can see that all the solutions are going to land 180 degrees apart. So the first time it happens is 360, or I should say 180 degrees plus another 360 degree jump, and that gets us point number one. So 360 plus 180 is 540. So that's one of our correct answers. In fact, I'll label that as that's that first intersection point I labeled there. Now, if we go 360 degrees further down from that, we'll get point number three. So 540 plus 360, 540 plus 360 is 900, I believe. And that is point number three on my labeled graph. The other one is, let me use my highlighter here, is the original principal value plus 360 plus another 360 to get to a grand total of 720 here for the second point. So this is two complete hops from our principal value at 0. Gets us out to a nice round 720. Now the thing you want to remember is all three of these angle values fall within the stated interval that we were limited to. I hope that helped.